So this is where we left off on the previous video. So we're going to pick up right after that with just practicing finding the roots. All roots, real, imaginary, whatever. And this time I'm just going to sort of work through it and see what we get. So starting with possible rational roots. I don't know why I just put an S there. So I'm looking at plus or minus 1, 2, 3, all the factors of 6, and then also the other factor of 3 is 3, so 1/3, 2/3, no need to write down 3/3, no need to write down 6/3 because those are already accounted for in the problem. So as we go to synthetic, we only have to find one that works to get there. And another clue, as you think about all the other things we've learned, notice that we're going from a positive to a positive to a positive to a positive. So none of these positives will work because there's no sign changes. So the only possible thing that I hope that makes sense when you look at synthetic, because your goal is to get a remainder of 0. Well, how can you get a remainder of 0 if you keep multiplying by, let's say, positive 1? Positive, positive, positive. Nothing will go away. So as you were just guessing something, maybe try -1. I have no idea if it works. That didn't work for me. So I'm just going to back it up. Try, well, let me write down 3 first. So make that -6, 2, -4. That didn't work. So we need to get a remainder of 0. It might help some of you to think about how this needs to be -6 then to get a remainder of 0. And it's okay to struggle through this. There's nothing wrong with... that's wrong. So I'm just kind of going through the options. What's that, -18? So that's -10. Oh my goodness, that's going to be really bad. So we've tried all of the integers. Maybe go on to -1/3. Alright, so that would be -1, which is 7. Oh my goodness, that's not even an attractive number. So that didn't work. And we're left with the very last possibility, -2/3. So the 3's would cancel. So 6. And let's see, 6 times 2 is 12, divided by 3 would be 4, which is 9. And then 9 divided by 3 is 3, times -2 is -6. Yep, there it is. X equals -2/3. And now we're down to a quadratic, except I would even factor out a 3 there. And you're left with x squared plus factoring out a 3 gives me 2x plus 3 is equal to 0 because we're finding the zeros. And your quadratic formula would say -2 plus or minus the square root of 2 squared minus 4 times 1 times 3 all over 2a. Notice that I'm ignoring the 3 at this point because this 3, imagine I divide it over 0 divided by 3 is still 0. So that's why I'm not considering this. My a value is 1, my b value is 2, my c value is 3 in the quadratic formula. So to finish that problem, I'll just stick with the same color. -2 plus or minus, this is 4 minus 12 is -8. And I hope you're good with this. It's 2. I like to put the I in front. Root 2 all over 2. And then you can simplify that as -1 plus or minus I root 2. Because each piece is divisible by 2. And there's your 3 roots. A positive and a negative imaginary here, the complex conjugate, and then -2/3 there as well. So I think we're ready for the very last problem here. Again, feel free to try this on your own. Notice I'm not even going to a graphing calculator, and I think it's pretty evident I didn't have the answer here. I literally went through every single possible answer. So our possible roots are plus or minus 1, plus or minus 3, plus or minus, don't forget about other factors of 6, so that would be a 1/2, 3/2. Notice that sometimes I switch back and forth between writing all the plus or minus. Anyway, plus or minus 1/3. I don't have to write down 3/3 because that's 1, and then plus or minus 1/6, but I don't have to write down 3/6 because that is 1/2. So I'm just guessing right now. -6, 1, 4, 10, 3 to get a remainder of 0, and that can only happen is if I get a -3 right here. So all I'm doing is just setting up the problem, and a lot of students tend to start with 1. There's nothing wrong with starting with 1, and there's only so many possible routes, to get there. And that's not going to do it for me. So I've had students just switch over to -1 and see if that helps. That did not help. Alright, so we use both of those options. Just switch over to 3, although this one seems to be a ridiculous answer. Maybe. Yep, I'm already at a really large negative number. There's no way to get that one smaller. Again, some students will just switch over to the negative version of it. So feel free to pause this video and try and do it on your own. Pretty sure that's not going to work for me though. So to speed this up a little bit, I'm going to jump over to -1/3. Trying this one out. As at this point, I just kind of want to hurry up and help you out. That 6 divided by 3 is 2. The negatives cancel, so we're at 3 divided by 3 is 1, -1. Again, we get 3. Again, we get -1. We get 9 divided by 3 is 3 with a negative there. So -1/3 works. Now, instead of starting over and trying again, just continue on until you get a 0 here. Now, here's the thing. If 1, -1, 3, and -3 did not work up here, is it even possible for them to work down here? No, it's not possible. And then again, you just might want to try some different options here. -1/3 could work again, for the record. But I went ahead and looked at the answer key, which has 3/2 working for me. So -6 times 3 is -18 divided by 2 gives me -9. Adding down gives me another -6, which is actually kind of nice. Gives me the same value, which is actually kind of nice. Gives me the same value, which is actually kind of nice because it gives me the same value, which is what I need to get 0 as my remainder. So there's our two roots, -1/3, 3/2. And now I have a quadratic where I can factor out a -6. So now I can just write it as x squared plus x plus 1 is equal to 0. And just like over here, remember, you can treat this -6 as if you divide it over, because we only care for the x values. So a value is 1, b value is 1, c value is 1. So it's -b plus or minus the square root of b squared minus 4 times a times c, all over 2 times 1. And as we simplify that, 1 minus 4 is -3. Again, I like to write my I in front of the root all over 2. And there's nothing to simplify there. But then don't forget about your other roots either, the ones we found earlier. All right, so if you start to struggle, feel free to go to a graphing calculator and narrow down your choices. This homework can take you a very long time if you're guessing every single problem. Just as a heads up. So make sure you start early, and there's a lot of guessing and checking. So have fun.